Welcome to the DIY Honda Garage channel. Diagnostic Trouble Code, DTC P0102, indicates a low voltage issue in the mass airflow MAF sensor circuit. The MAF sensor measures the amount of air entering the engine, which is crucial for the engine control module, ECM, to calculate the optimal fuel-to-air ratio. Located in the intake air duct, it can be prone to issues such as wiring problems or sensor failure. The error suggests that the sensor may be providing insufficient voltage, indicating a potential malfunction in the sensor or associated wiring. Before commencing troubleshooting, it's essential to record all freeze data and onboard snapshots, as they may provide context to the intermittent failures that may occur. Reviewing general troubleshooting information also assists in a structured approach to identifying and resolving the issue effectively. The mass airflow MAF sensor plays a pivotal role in the engine's fuel management system by measuring the volume of air entering the engine. This measurement allows the engine control module, ECM, to adjust the fuel injection accordingly, aiming for optimal combustion and performance. The MAF sensor is typically located in the intake air duct between the air filter and the throttle body, making it vulnerable to contamination and wiring issues. When the DTC P0102 is triggered, it often points to either a problem with the sensor itself or the electrical circuits connected to it. Ensuring that the MAF sensor is clean, securely connected, and free from damage is critical for accurate readings. Any low-voltage signals can lead to poor engine performance, increased emissions, and can ultimately cause engine management issues. Multiple factors can contribute to the triggering of DTC P0102. One common cause is poor electrical connections that can arise from corrosion, dirt, or loose terminals at the MAF sensor, intake air temperature, IAT sensor, or engine control module, ECM. Shorted or open wires in the IG1 ACG and VGP lines can disrupt the voltage flow, leading to the low voltage reading indicated by the DTC. Furthermore, a faulty MAF sensor may simply fail to provide the correct voltage due to internal defects or damage. Each of these factors can independently or collectively impact the vehicle's engine performance by compromising the ability of the ECM to accurately calculate the fuel-air mixture. Therefore, it is crucial to systematically diagnose and test each of these potential sources of failure. When DTC P0102 is present, drivers may experience a range of symptoms indicative of engine trouble. One common symptom is poor engine performance, which can manifest as rough idling or hesitation during acceleration. Additionally, the vehicle may demonstrate increased fuel consumption due to the incorrect air-fuel mixture being supplied to the engine. This can also lead to diminished throttle response and sluggish behavior. The check engine light, CEL, will illuminate on the dashboard, signaling that an engine-related issue has been detected. If the underlying problem remains unaddressed, it may lead to further complications, such as failed emissions tests and decreased overall drivability. Recognizing these symptoms early on can facilitate timely diagnostics and repairs. The first step in troubleshooting DTC P0102 starts with problem verification. Begin by turning the ignition switch to the on position, 2, and allowing it to sit for about 2 seconds. This step is crucial as it enables the vehicle systems to initialize correctly. Next, access the engine control module, ECM, data using the Honda Diagnostic System, HDS. Focus specifically on the MAF sensor reading in the data list. If the reading indicates approximately 0 grams per second, G/second, or a voltage of 0.1 volts or less, this confirms the failure in the system. In such a case, you would proceed directly to the second troubleshooting step. Alternatively, If the readings do not show these low values, it may indicate an intermittent failure. This could lead you to inspect for poor connections or loose terminals at both the MAF sensor/IAT sensor and the ECM. Step 2 involves checking the integrity of the wiring associated with the ignition circuit. To do this, turn the ignition switch to the lock position, 0. Following this, locate and examine fuse number B2, which is a 15-amp fuse found within the under-dash fuse/relay box. A functional fuse is critical as it provides the necessary power to the MAF and IAT sensors. If the fuse is intact, it indicates that the IG1 ACG, Ignition 1 Accessory Ground, and IG1 FM, Ignition 1 Airflow Meter, wires are likely not shorted, allowing you to proceed to the next step. However, if the fuse is blown, this indicates a short circuit in the wiring between the MAF, IAT sensors, and the fuse, which would require you to repair the wire short, replace the blown fuse, and verify the repairs before moving forward. In the third step of troubleshooting, the inspection focuses on checking for open wiring in the circuit. Begin by turning the ignition switch to the lock position, 0, and disconnecting the 5P connector for the MAF and IAT sensors. This disconnection is essential as it isolates the sensors from the circuit, allowing for more accurate measurements. With the connector detached, turn the ignition to the on position, 2, again. Now, measure the voltage between test points 1 and 2. Test point 1 corresponds to the MAF sensor, IAT sensor, connector number 3, white wire, and test point 2 is the body ground. If a battery voltage reading is present at test point 1, it confirms that the IG1 wire is functioning correctly, leading you to progress to the next troubleshooting step. Conversely, if no voltage is detected, it indicates an open circuit in the IG1 wire that needs repair. The fourth step centers on determining whether issues exist within the VGP line. Start by turning the ignition switch to lock, 0. With the MAF IAT sensor 5P connector still disconnected, measure resistance between test points 1 and 2. Specifically, connect test point 1 to the MAF sensor IAT sensor connector, number 5, light blue wire, and test point 2 to the body ground. It's essential to verify that the resistance falls within the specified range of 190 to 210 kiloohms. Achieving this range indicates that the VGP wire is intact. However, if the resistance is outside of this range, it suggests a problem that needs further investigation. In that case, the next step would involve examining the VGP wire for any shorts or opens that could be affecting its integrity. In step 5, the focus shifts to checking continuity in the VGP line. First, ensure you've jumped the SCS service connector switch line using the HDS. This step is crucial as it allows for proper continuity testing without interference from other systems. Then, disconnect the ECM connector B, 49P, to isolate it from the MAF IAT sensor circuit. Proceed to check for continuity between test points 1 and 2, where test point 1 connects to the ECM connector B number 22 LT blue wire, and test point 2 connects to body ground. If continuity is verified, it indicates that the VGP wire has a short. At this stage, repairs should be made. Conversely, if there is no continuity, this suggests that the VGP wire is intact and that other issues may need to be examined. Step 6 focuses on further continuity checks within the VGP line. Begin with the ignition switch in the lock position, 0, and ensuring that both the MAF IAT sensor 5P connector and the ECM connector B, 49P, remain disconnected. As in Step 5, you will check for continuity between test points 1 and 2, where test point 1 corresponds to the ECM connector B, number 22, LT blue wire, and test point 2 corresponds to the MAF sensor, IAT sensor, connector number 5, LT blue wire. Achieving continuity confirms that the VGP wire is functional and intact. If continuity is established, you should then consider updating the ECM software if it is not current, or substituting a known good ECM. However, if there is no continuity, it indicates an open circuit that will need to be fixed before moving on to further repairs. In the final troubleshooting step, the approach involves directly examining the MAF sensor IAT sensor's actual performance. Start by substituting with a known good MAF sensor IAT sensor to rule out the possibility of sensor failure. Reconnect all connectors before turning the ignition switch to the on position 2. The next action is to clear the DTC from the system using the HDS. After clearing the DTC, start the engine and maintain the speed at approximately 2,000 revolutions per minute, RPM, in neutral. Monitor the system for any pending or confirmed DTCs using the HDS. If DTC P0102 reappears, it confirms that the MAF sensor, IAT sensor, is functioning correctly, and you may need to update the ECM software or use a different ECM. However, if the code does not reappear, you will need to replace the original MAF sensor IAT sensor and ensure to conduct further repair verification. To ensure that all repairs and replacements have been successfully implemented, begin by turning the ignition to the lock position, 0, and reconnecting all relevant connectors. This step is vital to ensure that the electrical circuits are complete and can facilitate normal function. Proceed by turning the ignition switch to the on position, 2, once again. Use the HDS to reset the engine control module, ECM, and perform the ECM idle learn procedure. After that, check for any pending or confirmed DTCs. If DTC P0102 is still indicated, this suggests that further investigations are necessary. In this case, focus on inspecting for any loose terminals or poor connections at the MAF sensor, IAT sensor, and ECM. If the ECM was updated or replaced during the course of troubleshooting, conduct another round of checks. Ensuring diligent verification will help confirm that no underlying issues remain. Taking proactive measures can help prevent issues that lead to DTC P0102 in the future. Regularly checking the condition of the MAF sensor is a vital aspect of maintenance. This includes inspecting for dust, debris, or physical damage that could affect its performance. Additionally, ensuring that the wiring connections for the MAF, IAT sensors, as well as the ECM, are secure and free from corrosion can significantly reduce the risk of electrical failures. Scheduled inspections can aid in identifying potential problems before they evolve into full-blown faults. Perform routine diagnostics and cleaning of the sensors as part of the regular maintenance schedule. By staying ahead with preventive measures, vehicle owners can enhance performance and ensure longevity of their Honda Civic. In conclusion, DTC P0102 serves as an important diagnostic tool that highlights potential issues within the MAF sensor circuit. The MAF sensor is crucial for effective engine management, and understanding how it interacts with the engine control module, ECM, is essential. The systematic troubleshooting approach helps ensure that each potential point of failure is addressed, from electrical connections to sensor performance. By following the detailed steps outlined in the troubleshooting guide, technicians can effectively identify and rectify issues, promoting optimal vehicle performance. Incorporating preventive maintenance practices can also enhance reliability, safeguarding against future faults. Staying organized and knowledgeable helps maintain the vehicle's health and functionality. Please like and subscribe to the channel. See you next time.